example number 3, again, here are the steps. The first step is always to factor completely. So here, top can't be factored, but the bottom is a difference of squares. We get x plus 2, x minus 2. We can then list our non-permissible values and say that x can't equal negative 2 and x can't equal 2. Neither of those non-permissible values disappear, right? If a non-permissible value cancels out and goes away, it's going to be a whole. If the non-permissible value stays, they will both become vertical asymptotes. So we will have vertical asymptotes at x equals negative 2 and x equals 2. So again, what we're doing for all of our examples in 2.3 is we're graphing them completely. That way you see all of the characteristics right from the beginning. Next, we have to determine if there are horizontal asymptotes or oblique asymptotes. What situation do we have here? The degree is larger in the denominator. So we have to recall, if the degree is larger than the denominator, what kind of asymptote? Is that the example where we have oblique asymptote? Is that the example where it's always y equals 0? Is that the example where we look at the coefficients and figure out the horizontal asymptote that way? And it is the easiest one. If it's bigger at the bottom, when you put in a large number, the bottom will get bigger much faster than the top, and so you will have a horizontal asymptote at y equals 0. Next, we find our x-intercepts and y-intercepts. Oh yeah, I always find the y-intercept first because it's easiest. If you plug in 0 for x, look at your original equation. You're going to get negative 4 divided by negative 4. You're going to get 0, 1. And for your x-intercept, if you plug in 0 for y, and again, you just need to find out where your numerator would equal 0. My numerator is x minus 4. It will equal 0 at 4. So we can add our asymptotes. We have one at y equals 0, one at x equals negative 2, and at x equals positive 2. We can add our y-intercept at 0, 1, and our x-intercept at 4, 0. And once again, we have our x-intercept on the horizontal asymptote. That is fine. The horizontal asymptote is telling us what happens at the extremes. Vertical asymptotes are about non-permissible values. So you can never have your graph go through a vertical asymptote. It is possible for a graph to go through your horizontal asymptote. Now, we also need a point in each section, at least one point in each section. Sometimes you're going to maybe need more. So for example, we have a point in the middle section. The middle section, you have enough information to graph towards the asymptotes. I know it has to go up towards the asymptotes, because if I went down, I would get more x-intercepts, and I already figured out all my x-intercepts. I don't have anything in this section. X is less than negative 2. So I get a nice point, and I say, well, I'll pick negative 3. What would happen if I plugged in negative 3? And I'll do it in purple here. Can you see that the top would be negative 7? This one would be negative 1, and this one would be Negative 5. If I plugged in negative 3 for all the x's into those factors, I'm going to get negative 7 over positive 5. So I can put that point on my graph, negative 3 comma negative 7/5. And now I have enough in this section to graph. And then in the section where x is bigger than 2, we run into a little bit of a problem. I have a point, but it's already on the asymptote. So I don't know if I should go up towards this asymptote or down, and what I should do around it. So I'm going to find a couple more nice points. I'm going to plug in 3 and find that, and I'm also going to plug in 5 and find that. Again, to find a nice point, you just go to your factored form. I'll do it again here in purple. I'll erase this. If I plug in 3, the top will be negative 1, and this will be 5, and this will be 1. Can you see that you would get negative 1/5? If you plug in 3, you will get negative 1/5. So go down here, I'll add that in, negative 1/5. And that tells me I have this point right here, 3, negative 1/5. And this is enough information on this part to tell me, oh, it had to be going down towards the asymptote. If I plug in 5, five minus 4, this will be 1. 5 plus 2 is 7. 5 minus 2 is 3. I'll get 1 over 21. That point would be about here. 5 comma 1 over 21. Means it goes up for a little bit, but then comes back down towards our asymptote. Again, the horizontal asymptote, your graph is going to approach that at the end behavior. So again, a little bit of a different graph, but the steps stay the same. Every single time, you are going to find, you're going to factor, then you're going to find all your asymptotes. So steps 2 and 3, you can remember them as, I need to find all my asymptotes. Then, intercepts and nice points. Find as many points as you need to be able to graph it towards the asymptotes. In this example, we needed to find an additional 3 points to get a sense of what was going on. Sometimes you don't need to find any extra points. Okay, but every graph has a little bit of a different look, which means you need lots of practice, but the idea and the steps of every graph is the same. So let's look at B. In B we have x squared minus 4 over x squared minus 9. We start by factoring completely. Both are differences of squares. And sort of non-permissible values. X can't equal negative 3 and x can't equal 3. Do any of them cancel out? No. Since they don't cancel out, we know that we have vertical asymptotes at x equals negative 3 and x equals 3. Next, we notice that we have the same degree on the top and the bottom. What situation is that? Is that a horizontal asymptote or a oblique asymptote situation? Is it the one where it's always y equals 0? Is it the one that we look at the coefficients? Is it the one where we do synthetic division? So here is the one where you look at the highest powers when they're the same. You have 1x squared over 1x squared. That simplifies to 1. And so we have a horizontal asymptote at y equals 1. Plug in 0 for x, and you'll get 4 over 9. Plug in 0 for y, and this is where I would look at my numerator. My numerator is already factored, and there are two places where the numerator would be 0. You would have one at -2, and the other one at +2. So you will get very good at finding x-intercepts and y-intercepts quickly. Then I would start graphing to see if we need any more nice points. So we know that we have asymptotes at -3 and +3, and a horizontal asymptote at y equals 1, 0,4 is our y-intercept, and -2, 0, and 2, 0 are our x-intercepts. We have a lot of points in the middle section. In fact, in the middle section, you have enough information to draw the middle section towards the asymptotes. Goes through those points and towards the asymptotes. What we don't have is points in the section when x is less than -3, and a point in the section when x is bigger than -3. So we make those our next nice points. I will choose -4 comma something and +4 comma something. Right? If you plug in -4 and do the mental math, you see that you would get -4 plus 2, -2, -4 minus 2, -6, -4 plus 3, -1, -4 minus 3, -7. That simplifies to 12 over 7. So that is my one nice point. So I go to -4, and I label -4, 12 over 7. I have to recognize that 12 over 7 is a little bit bigger than 1 to make sure that it's above this asymptote. And now I have enough to draw that section. If you plugged in +4, take out my eraser here. If I plug in +4, I'm going to get 6 and 2, 7 and 1. It's also 12 sevens. And maybe you could have recognized that if you looked at the original equation. Can you see if you plugged in a 4 or a -4 with an x squared where it is, it wouldn't make a difference. If you square -4, you square +4, it'll be 16 no matter what. So we get 12 over 7 again. You can label that point over here at 4, 12 over 7. And we have enough for that part of the graph. Now, sometimes you get domain questions in something like this. The best way to do the domain questions is to say, instead of saying what x can equal, you can just say x can't equal plus or minus 3. But x is everything else. Sometimes you'll see they'll still list x is everything except x can't equal 3, and x can't equal -3. That is usually a strategy for this. The range, though, is a little bit trickier because the range, the y values are less than or equal to 4/9. That's this bottom part. Or y is bigger than 1. Because the asymptote is at 1, and it's everything bigger than that. Okay. I'm going to get you to write down questions 9 and 10. I'm going to paste the steps up here. And we're going to start with question 5 from the homework.